Hello, this is how to write a Linux shell script that creates a Linux virtual machine using QEMU. Then inside that virtual machine enables the SSH server and then connects to the virtual machine using the SSH protocol. As an example, we're using the Linux operating system KDE Linux, which we're going to run inside the QEMU virtual machine. From the kd.org, the homepage of the KDE community, at the very bottom there's products and KDE Linux, and then you can follow its progress here. Takes us to the KDE wiki page for KDE Linux. Let's read a bit how to create the virtual machine. The example here is using the virtualization software Virt Manager, so virtual machine manager. We're not using raw QEMU yet. These are the files that are available. It's a pair of a torrent file and a raw file. We're only interested in the raw file. Then it says that you should download that raw file and make sure that the sums are correct. For instance, the SHA-256 sum. We already did that. We downloaded one of the raw files and renamed it simpler without any version, kd-linux.raw. Next up, it says that we should create a virtual machine, and not the classical way, which is add an ISO to the CD-ROM drive of the virtual machine, but in this case we're importing an existing raw disk image that we're going to use as a boot medium, and that will allow us to run in a way that's similar to a live CD environment. So this is what we want to do. We want to boot from the raw file in live CD mode. The operating system will be installed. There will be a graphical user interface session, KDE Plasma 6, Wayland, and we want to connect to that live CD session using the SSH protocol. This is for automating installing the operating system and then making sure that the operating system has been installed correctly. We want to test that the raw file did not regress. So it's part of automated scripted testing. Okay, so the first thing that we want to do is to boot the raw file, but there's a catch in here. It says that it only supports UEFI without secure boot. Let's see how we can do that in using raw QEMU, not Virt Manager. We're using QEMU because we want to automate everything from a bash script. This example is interactive, where the user clicks in various places in the graphical user interface of the application Virt Manager. Okay, we have a wiki page, kd-linux/more, and I have already documented this process, so let's see if we can follow the process correctly. We have the raw file. Let's open a terminal. Okay, and this is how you boot the raw file. We're going to specify UEFI. So in order to specify UEFI, you need this long incantation. And we don't want secure boot, so you will need to select the correct UEFI image from EDK2. That's also going to depend, the full path of this firmware file is going to depend on your operating system. I'm on Kubuntu 2504, and this is the path for the files. Let's see a bit all of the files available there. So we're using the simpler one. There are also secboot variables And this is the firmware, so the UEFI, but there's also a pair to this, which is the UEFI variables. If you want to edit the, as it were, the BIOS setup screen, but we're not going to do that. We're going to just keep the defaults. So we're not needing the _vars_ files. Okay, so we selected the UEFI firmware that doesn't require secure boot. And then we're specifying the file that we want to boot from, which is the raw file. In order to suppress a warning that QEMU uses, we're specifying that the format is raw. We want to use the hardware virtualization. We want to use a certain amount of random access memory and virtual CPUs. We're on AMD 64 CPU, and also the virtual machine is AMD 64. I'm going to increase a bit the amounts of random access memory and virtual CPUs. Let's do that. So 10 gigabytes of random access memory and 14 vCPUs. So let's see a bit how this operating system works. This is the bootloader, the bootloader menu. The bootloader is systemd-boot. It has a 5 seconds timeout, which it would be great if we could automate. So from outside the QEMU, we want to automate the QEMU window. We want to not wait that 5 seconds timeout. We want to insert an enter key there. And then after the operating system finishes booting, including starting the graphical user interface session, logging in as the user demo without a password, and starting the graphical user interface session in live CD mode, we want to automate this QEMU window and do the following. So the Linux operating system that we have just booted into does have an SSH server, but the SSH server is not yet enabled. And if we would be able to enable the SSH server and make it possible to connect to the virtual machine using SSH, then we could run the rest of the automation that checks that the raw file doesn't have any regressions. As you saw, the raw file is generated at least once daily. So there's a CI/CD pipeline that generates this raw file 5 gigabytes. And we want to make sure that as new versions appear, the operating system continues booting, the Plasma session continues to load correctly, at least that there are no regressions from a version to the next. Okay. If you were to do this everything very manually, you would have the QEMU virtual machine. You would probably start console, as this is the terminal emulator graphical user interface application that's pre-installed. And then we want to enable the SSH server. Copy paste doesn't work, so you need to paste manually. Systemctl. So enable now does two systemctl actions. The first one is enabled, that creates the symlink, and then now means that it's also going to run something similar to systemctl start SSHD. So it's both enabling and starting the service. But now we cannot connect to the QEMU virtual machine because the default networking that QEMU provides is using Slurp. It's makes it possible from the virtual machine to connect to the internet. We can also connect to the host machine because that's the way the IPv4 networking has been set up. It's using a DNS server provided by QEMU in this range 10.0.2.0/24. The DHCP leases start at .15. Okay. So we also need to start QEMU in a way that will expose at least port 22 from inside the QEMU virtual machine and do port forwarding towards the local host network interface card, the loopback network interface card on the host machine. Let's see how I did that. This is the thing that we're after. You might use the default network interface card that's provided to virtual machines. No need to go to virt.io. That would simplify a bit the command line, so you don't need this line and probably also this part. I have seen various issues related to IPv6. Maybe it's my networking, so it's a good idea to disable IPv6. We don't need it for this test. And this is the magic where it says that port TCP22 from the virtual machine is going to be forwarded to all network interface cards on the host at TCP port 5522. We can just close the virtual machine. Everything that we do inside the virtual machine is read-only. There's no permanent storage. There's no virtual hard disk. We did not create a QEMU image that we want to install the operating system to. We're just running in live CD mode, so it's extremely easy to Control-C the QEMU process. Close it. There's not going to be any problems. Okay. Let's see where we get with this. So we still wait 5 seconds. There's no automation yet. We're trying to see if we can do everything manually, and then we're going to automate everything. So the virtual machine's finished starting. We have the TCP forward rule. So we're going to enable the SSH service again. We'll launch console. Okay. Back to where we were. Sudo mctl. Okay, in a second terminal tab, we're going to try to connect to the virtual machine. So the incantation is going to be something like SSH, and then the port and the username is live, as we can see in the prompt. The user that has been created as part of creating the installation medium for the Linux operating system is called live, and we don't yet know its password. So let's connect and see. So SSH -p5522 username and localhost. Okay, it says that it saw this machine before. Whenever we're booting the virtual machine, it's going to create different pairs of private public SSH server keys. So we're going to run this command line a lot. SSH minus keygen minus F, known hosts, remove, and then what? It could connect to the virtual machine. That means that the TCP forwarding rule works. That means that the SSH server OpenSSH is running on the virtual machine listening. We acknowledge the pair of public-private keys of the SSH server, and we're trying to log in as the user live. Without password, we could not log in. We don't actually know the password. It's not live. So let's see if we can log into without using the SSH protocol. We're going to use a VT, virtual terminal, straight from the Linux virtual machine. So that can be done by pressing Ctrl-Alt-F3. This is an operating system that's based on Arch Linux. It has the graphical user interface session on VT1, and on VT3 we can log in text user interface mode. But the way to do it is by using monitor inside the QEMU graphical user interface. So that's sendkey, Ctrl Alt F3. Back to the VGA, and now we're on VT3, and we want to check that the password of the user live does not exist. So Linux username is live, no password required, it automatically logs in. So that must, or probably is, meaning that the SSH server is configured to not allow empty passwords. Let's prove that's the case. We use the text editor nano. So etc ssh sshd. I don't really know how to use zsh, so let's go back to bash. Okay, it's the configuration file for the SSH server sshd_config. And let's search for password. How do we do that? I don't know in Nano how to do that. Says permit root login prohibit password, so the user root cannot log even if we know the password of the user root. But we want to log as the user live, which was pre-created, and it's a sudoer. Permit empty passwords, no, on this line. So that's what it is. The user live exists, has no password. We cannot log in using SSH because the user live does not have any password. So we'll need somehow to set a password for the Linux user live. Let's see how we do that. We can do that by using the command line password. We're going to provide the password that's identical to the username, so just live. And now when we want to connect, live, and we were able to do what we're after. So we want to do programmatically this scripted in a bash script. We managed to do all of this manually by clicking and running commands. Let's see how we can further automate everything. So as you saw, we're using the compat monitor 0 in the QEMU graphical user interface application, so in this window. We can get at that by appending to the QEMU system x86-64 command line, the command line that actually starts the virtual machine, the command line parameter minus monitor stdio, which means that we'll be able straight in here to run the commands that we are running inside the compat monitor 0. Let's see how that works. Just closing the QEMU virtual machine window will stop the QEMU system x86-64 process. We'll also log out the SSH connection. Okay. Let's see what's happening in the console. We have the monitor, so we can just issue commands in here. If we want to not wait that 5 seconds, we can send the command line enter, and then we can also specify how much time in milliseconds to wait for the operating system to finish loading and getting to the graphical user interface. So in this case, I'm waiting 20 seconds, which is more than enough. The operating system boots in around, I don't know, 11 seconds. So let's see if we can send Ctrl-Alt-F3 straight in the console terminal in this first tab. This time we have copy-paste working. It's waiting 2 seconds because switching terminals takes a bit. Let's see how it looks like. Yes, we're inside the VGA VT3. And the monitor is not available in the QEMU window in the main menu view, because now it's bound to the terminal. Okay, and then using sendkey we can automate everything that we did interactively. All of the characters that we have typed inside the VT3, we can type them from the QEMU monitor. So we want to say live and then enter, which will actually log into the operating system using the user live without any password. Ctrl-Shift-V. Okay, so it wrote live and then pressed an enter, and now we have connected. Next up, we want to run the command line sudo systemctl enable now sshd. We also want to change the password of the user live. That can be done by interactively by piping the password towards the standard input of the command line password -s, but then -s parameter of the password command line requires that you are the user root, so you must prepend everything with sudo. So this is all of the incantation, single line, that we need to run inside VT3 such that the SSH server is enabled, the user live gets the password live, and then that will enable us to connect to the virtual machine using the SSH server. But we must send each and every key press independently on its own send key line. So sendkey S, sendkey U, sendkey D, sendkey O. This is the how you pass space character, and then systemctl, another space, and then minus, which is minus. Okay, in order to simplify this, we're using a file that exists on the internet that's called sendkeys, written in Ruby in this GitHub repository mvidner/sendkeys. Let's see how that looks like. It's a one page, doesn't use any special Ruby packages. You just need to have Ruby installed. If it's not installed on your operating system, you can install it. It's converting minus to the text minus, etc. SPC, enter is return. Okay, and then you can run it like this: Ruby sendkeys, the name of the file that you have just downloaded from this page, and then between single quotes, because we're inside the bash shell and we don't want anything to happen. We don't want, for instance, to have this create two processes. Okay, so this is the end result. Let's copy it. Again, we can just copy paste in the console tab. It already did this thing, so it typed all of these characters one by one. This has enabled the SSH server, started the SSH server, and changed the password of the user live to be live. Let's now connect. This is the incantation. First, we're removing the record from known hosts, and then we're sending the password live to the SSH process, which is the SSH client. For that, we want to install, there's many ways of sending a password towards the SSH process. One of the ways is using the SSH pass package and executable. You can also use expect, Perl, Ruby, etc. Let's see that SSH pass is already installed. And it is. And now we can run this part to connect to the virtual machine. And we're inside the virtual machine, connected correctly, which is what we were after. We wanted a simple way bash script to start the virtual machine and manipulate the virtual machine, in this case to enable the SSH server and set a password for the user live. And then we have the needed shell script to log in using SSH. And from here on, there's a totally different part, which is going to be the actual automated testing to make sure that the live CD like session of this operating system KDE Linux works correctly. We will check that executables exist. We will check that graphical user interface applications start correctly. We will see that the Flatpak applications have been installed correctly, that there are no snap packages installed, etc. So this was it. This is how to automate installing a Linux operating system, the install medium, in a QEMU virtual machine, and then using the QEMU sendkey automation, we're doing additional enablement inside the virtual machine Sometimes the virtual machine comes with everything available by default, in the sense that the SSH server is pre-installed and running, that there's a Linux user with password that we can use to connect remotely, and then maybe the SSH functionality is disabled once you actually install the operating system. So right now we're only running the operating system in live CD mode. Let's see how we send switch back to the VT1 where the graphical user interface session is. Now the Plasma lock screen is asking for a password. Previously it did not do such a thing. And this is again live CD mode. You're supposed to use this mode just to make an impression if this operating system is for you, if this operating system maybe supports your hardware. But then immediately after, you're going to actually install to a disk, to storage, using the Calamares installer that you can access either by clicking on this icon or on this icon. Let's see how we do that. We made everything harder by adding a password to the user live. Okay, we don't have any additional virtual hard disk, which the procedure asks that you create. So it says that you should add another QCOW virt.io storage of 200 gigabytes. We don't have that. We did not specify when we're starting the QEMU virtual machine that we want a second QCOW disk. So the installer, Calamares, will not allow to proceed with installation wizard. So this is it. Thank you.